The vertical milling machine is surpassed only by the lathe for versatility in machining operations. In addition to the vertical milling operations, the machine can also be used for precision drilling. When fitted with special attachments, it can perform horizontal milling and slotting operations. After viewing this videotape, you should be able to list safety precautions used in the machine shop and when operating the vertical milling machine, name the parts of the vertical milling machine, and explain how each part is used in the overall operation of the vertical milling machine. Some safety precautions to observe in the machine shop while operating the vertical milling machine are: always wear eye protection, such as safety glasses. Remove watch, rings, and other jewelry. Wear short-sleeved shirts or roll sleeves above the elbows. Be sure all machine guards are in place before starting any machine. Keep the machine and the area around the machine clean. Wipe up any coolant or oil spilled on the floor. Remove chips from the machine with a brush. Do not use air hoses to dust off the machine, as metal chips may be blown in the eye. And use correct cutter speeds and table feeds on the milling machine to prevent cutter breakage. The vertical milling machine is generally classified as a knee and column type machine. The name is derived from the two major design features: a main vertical frame member in the shape of a column and an adjustable knee-like projection mounted on the front of the column. Vertical milling machines must not be operated until they have been properly lubricated according to the manufacturer's specifications. Check the machine for level by placing a precision level on the work table in the longitudinal and transverse directions. If it is not level, make adjustments under the base of the machine. The vertical milling machine shown in this videotape is also known as a ram and turret mill because the milling head is mounted on a movable arm and the ram may be swiveled on a turret. The base and column of this milling machine are one casting. The base provides a stable support for the machine, and the column holds all the components of the machine. The ram, with all of its components, is attached to the top of the column. The turret connects the column and the ram. The turret can rotate about the vertical axis of the column, making it possible to position the cutter tool over any part of the work table. By rotating the turret 180 degrees, other attachments mounted on the opposite end may be positioned over the work table. The ram is positioned by loosening the vertical bolts which clamp the turret to the column and by swiveling the ram to the desired position. A protractor scale on the turret and an index mark on the column allow the operator to position the ram consistently and accurately. The ram, or overarm, has points for mounting and positioning milling and other attachments used on the milling machine. The ram can be moved on top of the turret by loosening the ram locking bolt and using the ram traverse lever to move it forward or backward over the table. An adapter head is attached to the end of the ram, which can accommodate the standard milling attachment. This adapter head allows the milling attachments to be tilted toward and away from the column face. Tilting is accomplished by loosening the horizontal bolts on the adapter head and turning the tilt control hex nut with a wrench. The adapter head and milling attachments can be accurately positioned at an angle by using the protractor scale and index mark. A standard milling attachment is mounted on the adapter head with 4 clamping bolts. The attachment is self-contained, having its own motor for driving the cutting tools and all the mechanisms necessary to perform the milling operation. The major components of the milling attachments are the motor, the belt housing, the quill housing, the quill, and the spindle. The motor drives a belt and pulley system. By changing belt locations on the pulleys, different spindle speeds can be obtained. Some vertical milling machines are equipped with variable speed controls for regulating spindle speed. The quill and spindle are located within the quill housing. The spindle is the rotating component in which the cutting tools are mounted. The quill moves vertically and may be fed by hand or by power. Vertical movement of the quill also moves the spindle and can, therefore, control the depth of cut taken by cutting tools mounted in the spindle. A quill lock, located on the front of the attachment, locks the quill. The micrometer stop on the milling attachment can be used for setting depth in milling slots or gauging the depth of a hole. On the front of the attachment is the feed hand wheel, which is used for feeding the spindle either by hand or by power. On the side of the milling attachment is the rapid feed lever, used for feeding the spindle down or up. The spindle brake, located on the top of the attachment, is used to stop the spindle after the power has been shut off. A lever on the upper left-hand side of the head is used to control the direction of rotation of the spindle. This self-contained milling attachment head also has the following features: control levers for setting the feed rate on the power feed, belt shifting and tension control lever, a back gear control for changing to lower speeds on the spindle, and a drawbar, which is used for tightening a collet around the shank of a drill chuck or end mill to hold it in the head of the machine. The next major component of the milling machine is the knee. It moves on the ways machined on the front of the column and is also mounted on a vertical screw that can be adjusted up or down by means of a hand crank located on the left front side. The knee lock, located on the front of the machine, locks the knee in position when it is tightened. The saddle is mounted on top of the knee on machined ways, which allow it to move toward or away from the face of the column. The hand crank, located in front of the knee, provides the movement. The saddle lock, located on the left side of the machine, locks the saddle in position for machining operations. The table moves on ways machined on top of the saddle. Its movement is along the longitudinal axis of the machine and is controlled by hand cranks on either end of the table. In some cases, movement is provided by a power unit mounted on the right-hand end of the table. There are two common power feed attachments to the table: the gear-driven feed and the variable feed. The feed rate of the gear-driven feed attachment is selected by adjusting the gear range knob in either the high range or low range. The gear shift lever may then be placed in any one of 6 positions in the high range or 6 positions in the low range. The variable feed rate type operates electrically and is not limited by available gear ratios. Feed rates may be varied by turning a dial selector. Both power feed attachments control the table movement by a clutch handle, which engages the power feed and determines the direction of table movement. The table moves to the left when the clutch handle is moved to the left, and to the right when the clutch handle is moved to the right. The power feed may be disengaged manually by putting the clutch handle in the neutral position. It may also be disengaged automatically by setting the 2 stops located in the rod attachment to the clutch handle. The clutch handle is pushed into the neutral position when the table reaches one of the stops. Another feature of the variable speed is a rapid traverse. The rapid traverse is engaged by depressing the button beside the dial selector. When the button is released, the feed rate returns to the setting on the dial selector. The table can be moved along 3 axes: vertical by the hand crank on the left front face of the knee, transverse or cross feed by the hand cranks located on the front of the knee, and longitudinal by 2 cranks located at either end of the table. All table controls are direct reading dials. A 1,000th graduation on the micrometer dial represents 1,000th of an inch movement. The micrometer dials can be adjusted to an initial setting by loosening the lock nut, then setting the dial to the desired setting without moving the shaft. The lock nut must be tightened before the crank is turned. There are locking devices on all three axial movements to keep work accurately aligned. The knee lock, the saddle or crossfeed lock, and the table lock. It is a good policy to lock any component which will not be moving during the machining operation. Some vertical milling machines are modified to accommodate digital readouts for table travel, while others may be equipped with numerical control devices for automatic operation. This table has T-slots for mounting work directly to it, or for holding vices which hold the work. The milling head operating controls and features of the milling head attachment make the following functions possible: mounting the cutting tool, adjusting the RPM of the cutting tool, and vertically positioning the cutting tool. The cutting tool is held in the spindle with a collet. The keyway in the collet is matched with a key in the spindle. The cutting tool is made secure in the collet by applying the spindle brake and turning the drawbar knob with a wrench until it is tight. When the drawbar has been tightened, return the spindle brake to neutral. The collet and tool are removed by reversing the steps. It may be necessary to tap the drawbar knob with a soft hammer to free the collet from the spindle. The milling attachment motor drives a belt and pulley gear arrangement to rotate the cutting tool. All spindle speed variations are made by changing the belts on the pulleys. Use the high-low speed clutch and back gear control to select the speed range. When changing speed ranges, the direction of the spindle rotation will reverse because of the gearing design. The correct rotation of the cutting tool can be set by using the reversing switch. Always check tool rotation before beginning the operation and correct it if necessary by means of the reversing switch. Always replace the guard for the pulley and belt system housing before turning on the machine. Some milling attachment heads may be equipped with a variable speed drive. On these models, the proper spindle RPM is selected by positioning the variable speed drive to the desired setting. The vertical positioning or feeding of the cutting tool is controlled by the movement of the quill. The quill has a 5-inch range of travel and can accommodate precise adjustments by using the micrometer adjusting nut and the quill stop on the front of the quill housing. The adjusting nut travels on a threaded rod, which is placed parallel to a 5-inch scale. The scale is marked off into 20 graduations per inch, which allows readings to 50 thousandths of an inch. The vertical movement of the quill can be operated manually by use of the quill feed handle, which operates in the same manner as that of the drill press. The cutting tool is fed downward when the handle is pulled toward the operator and fed upward when pushed away from the operator. Manual feed is usually used for quickly positioning the cutting tool. The other method of feeding the cutting tool into the work is the power feed. This method is particularly useful in repetitive operations or operations that require a carefully controlled feed rate. To engage the power feed mechanism, stop the spindle and move the power feed transmission engagement crank to the in position. Set the feed rate by pulling the knob of the quill feed selector out and reseating it in any one of the 3 feed rates. The feed direction is determined by the position of the feed reversing knob, which is located in the manual feed handle or shaft. If the machine is in the high spindle speed range and the knob is pushed in, the spindle will feed downward. If the knob is pulled out, the spindle will feed upward. However, if the spindle speed is in the low range, the knob must be pulled out to feed downward and pushed in to feed upward. Place the knob in the middle or neutral position when the power feed is not in use. The micrometer adjusting nut is used to automatically disengage the down feed. When feeding upward, the power feed is automatically disengaged when the quill stop contacts a throwout pin. When beginning to feed, hold the feed control lever in the engaged position until the quill stop has moved off the adjusting nut or the throwout pin. In review, you have seen some of the safety precautions to be observed when using the vertical milling machine. The parts of the vertical milling machine, and how each part is used in the operation of the vertical milling machine. A vertical milling machine is a very versatile machine, and the machinist should be able to use the capabilities of this machine in the shop.